TJ, do the first one for me. Read it and tell us what you find.
What? Wait, what?
Read it and tell us what the claim is.
Security expert claims that at least 14% of all home workers have a security alarm system. Homeowners have a security alarm.
Okay, so how would you write your claim?
I said HO and I put P and I put less than or equal to 14 and that was my claim.
At least. At least means this is the least you have. Greater than or equal to. And how do we write 14 as a decimal? And you said this is the claim. Is this the HO or the HA?
HO.
HO because
It has an equal sign.
has an equal sign. HA would be what?
P is less than.
And the test follows the HA. Which way to bless you? Does the arrow point? Left. This is a left tail test. Okay? Second one. Dan, read the second one, if you would.
A manufacturer of Grant Other Clocks claims that the mean time its clock moves is no more than 0.2 seconds per day. 0.02 seconds.
Okay, so what's your claim?
The mean is less than or equal to 0.02.
Good. This is the claim, and this is the HO. Why is it the HO? Equal then sign. Good, the equal to sign. What would your HA be?
The mean is greater than 0.02.
And what tail test would you have?
Right tail.
A right tail test. It follows the HA. Good so far? Questions so far? I need you to be using your population parameters that are not only in your notes, but I probably keep writing the chart every day we meet. Aaron?
So the only rule is that AJ is always the tail.
That's not the only rule. The claim is whatever is stated. The HO has the equal sign. The HA does not have an equal sign, and the tail follows the HA. So you have to get used to that little routine. Okay, number 3. Julie. Read it for us.
A golf analyst claims that the standard deviation of the 18-hole scores for a golfer is less than 2.1 strokes.
Okay, so what's your claim?
H.
Okay, it's the HA, and how would you write this?
Standard deviation is less than 2.1.
2.1, good. And what's your HO? And what tail test do we have? Left tail follows the HA. Okay, good. Damani, next one. Oh, you got something in that. Aaron. Next one. You were eating.
I have a question.
Question.
So when it says standard deviation,
Yes. Yeah. Guys, knock it off. You have to put your population parameters, which I write every day on the board. Population, sample. Maybe this is a good time for you to write it down if you haven't. Mean for the population, X bar for the sample. All our claims are made about a population. We challenge those claims using a sample that we find. But we want to make this inference, this challenge against a population claim. This variance versus the sample variance, the standard deviation versus the sample standard deviation, and the proportion versus the p-hat. All of your claims are against a population. And when they make a blanket statement for a population, such as this report claims that 87% of lung cancer deaths are due to tobacco use. This is all population, the entire population. So now, me as a medical researcher say, I think that's true. So I create my sampling and I test against this population claim. So this is extremely important that you realize this is about a population, just like your confidence intervals are. So this is a proportion, And this proportion says what? Pete, how do I set this claim up? Equals 0.87, not 87. This is the claim. Okay, is this the HO or the HA? Because it has an equal sign. HA would be what? What's the complement of this? Not equal to. What tail test is this? Two tails. Okay. Make sure, guys, most important, that you're understanding. We're talking about a population claim.
So,
Yes.
or no, can you go back to number 3? I would.
Yeah, I can. It's not there, but we can talk about it.
I don't know. I thought it says it's less than 2.1.
Yes.
Why did like
It's a claim.
less? I thought it was the last than here, right? But
Less than.
where you put the final here?
Less than or equal to.
You have to say that.
If something is less than, if you have less than $5, do you have $5? No, or equal to. Okay? Less than or equal to, at most, maybe you're thinking at most. At most, if you have at most $5, can you have $5?
Yeah.
Or less, right? Okay. Okay, Dan. You do this one. Number 5.
Baseball team claims that the main line of this game is less than 2.5 hours.
So how do we write your claim?
M is less than 2.5. And that's for HA.
And how did you know this was HA?
Because it doesn't have equal to.
Doesn't have an equal sign. Good. What would be its complement? It's HO.
M is greater than or equal to 2.5.
Good. And what tail test do we have? Left. It follows the HA. Good. Okay, last one. Jada, try the last one.
A state claims that the mean tuition of this university is no more than $25,000.
So how would I write the claim?
The mean time is greater than or equal to,
No more than.
less than or equal to
Less than or equal to. Oliver, this is for you. No more than. Less than or equal to. 25,000. This is the claim. Is this the HO or the HA? HO. Good. What's the HA?
The mean is less than, it's greater than.
Greater than 25,000. What tail test do we have?
Correct.
A right tail test. This is a U, not an M, but it's called a mu. Guys, listen carefully. This is a Greek letter mu. It looks like a little scripted small u. It's pronounced mu. That's where we get the M from, but it's really a little u. Is that what that is? You never know. So you get your level of significance. And I'm on page 353. If you 353. So just read the top with me for a minute. Read the top of 353 with me. You will reject the null hypothesis when a sample statistic from the sampling distribution is unusual. You have already identified unusual events to be those that occur with a probability of 0.05 or 5% or less. Remember when we were looking at these with probabilities? Because 0.05, if we separate this, is your plus or minus 2. If you think back to your normal curve, think back to your normal curve, guys. This is really important. Here's your plus or minus 1. This was 68%. Here's your plus or minus 2. That was 95%, which means your tails add up to 5%. That's where the unusual comes from. Okay, it's really important that you understand this. When statistical tests are used, an unusual event is sometimes required to have a probability of 0.10 or less, or 0.5 or less, or 0.01 or less. Because there is a variation from sample to sample, there is always a possibility that you will reject a null statement when it is true. This is your type 1 error. In other words, the null hypothesis is true. Your sample determined it to be an unusual event in the sampling distribution. You can decrease the probability of this happening by lowering your level of significance. Okay? It's kind of the flip side of the confidence interval. You need it to be 95% confident. You're going to look for your error for the 0.05 level of significance. Okay, so now, very, very important is your level of significance is the maximum, and this is on your note page, is your maximum allowable probability of making a type 1 error. Type 1 error says you rejected the null when in fact it was true. Remember the type 1 and the type 2 errors we did yesterday? If the null was true but you rejected it, that caused you to be a type 1 error. It is donated by this little symbol. This is actually an alpha symbol. It's like a little A, and you write it like a little fish symbol like this. The probability of a type 2 is a beta, is the B. We don't deal with the beta at all. In our courses, well, we don't deal with the beta at all. If you look at the little box, it talks about, there's a little insight box on that page. When you decrease the alpha, the maximum allowable probability of a type 1 error, you are likely to be increasing the beta because it's the 1 minus beta. Okay? It's called the power of the test. It represents the probability of rejecting the null hypothesis when it is false. We don't do that part. We are only concerned about the alpha part in this course. And you really don't even see that because what ends up happening is you look at your level of significance, you test against your level of significance. But I want you to be aware what that 5% means. And when we look for reject regions, this will be a reject region. This will be a reject region. Okay, wherever our error will occur. Your error is a type 1 error. Okay? I just need you to make a little bit of sense out of it. What I'm looking for. A little bit of sense out of this. Okay. Your test statistic comes from your sample, whether it's your mean, X bar, your population, your proportion, P hat, or your standard deviation, S. This is what you test with because you disagreed with a population statement. So you gathered your sample randomly in the best way you knew how, and you pulled up your sample information. That was really bad. That was an apple. Since the level of significance, guys, this is really, really important. Since the level of significance is the maximum allowable probability, one way to decide if we should reject the null statement is to determine whether the probability of obtaining that little test thing that you did is less than that of the level of significance. A lot of words for a little thought. So what does that mean to you? Erin, what does that mean to you? I don't know. Nick, what does that mean to you? And Sue, what does that mean to you? I have no idea. Dantreus, what does that mean to you? Anybody paid attention to anything that I said? What does that mean to you?
That just can't test less than the level of significance.
There you go. That's all it is. You can't test less than that level of significance. Thank you, Oliver. So, when you're testing this, we're looking at the comparison to your level of significance. Not a tough concept. Thank you, Oliver. Okay. Guys, I'm not taking this as a joke here. I'm really not. Alright, so let's take a look at how we test these things. Your p-val, and we refer to this concept as a p-val. It is really a probability value. Where did we find your probability values, if you remember? Where did we find probability? 0 to 1. And where did we look for those things? Remember, we use your normal curve. We look for area under your curve. Isn't the probability the area under your curve? So we're still back to your area under your curve. We're looking for your p-val. The p-value is described of a hypothesis test. It is the probability of obtaining a sample statistic with a value as extreme or more extreme than the one determined from the sample data. P-val depends on the nature of the test. It depends where the tail is, because we're looking for the area under that curve. So it can be a right tail, a left tail, or a two tail. So for a left tail test, so if you take a look at this, for a left tail test, we always follow the HA. This is your p-val over here. This is your area under this curve. It is the same area that we look up whenever we find a z-score or anything else that we're doing. If you turn to page 354, this is where I'm getting this from. It is just to the area to the left of your test statistic, generally your z-score. Now, when we do this, and remember back to your table, we look up your area. It is your area to the left. This all goes back to table 4. The chi-square is the only one we do where it's the opposite. But we're back to your normal curve. The right tail test, all it means is you follow the tail for your HA. So in this case, I'm looking for this tail. My test statistic would be here, such as a z-score, whatever. And I want this area. Generally, to find the area to the right, you're going to look up your z-score, and what are you going to do from your table? Subtract it from 1. Okay? So those rules still apply. And that's why I went through the tail test at the same time as soon as we set up our things. Well, that's just a test statistic. Whatever value they put in there. A two-tail test, God bless you, is just that. It's two tails.
So we don't have to ever put K.
No, K is going to be your value that you're going to find. That's going to be your value to find. If you look at the two-tail test, guys, each of the areas, again, is split. You know how you do the 1 minus the thing, divide by 2? It's split. It shares it in two tails. So it still keeps that same concept. Later, when we actually test for a two-tail test, you're going to actually look up one of the tails, probably the left one, which is easier, and multiply that by 2. Wouldn't that give you both areas then if you multiply the left one by 2 or the right one by 2? Wouldn't you get both of them? Isn't the same as adding both of the same thing together?
They'll always be symmetrical.
Always symmetrical. We work off your normal curve. If it's not symmetrical, if they don't tell us again that we assume it's a normal probability of distribution, we can't do it. Okay, so let's take a look at this and see if we can kind of pull this together. This is important. The smaller the p-val, from 0.10 to 0.05 to 0.01, the more evidence there is to reject the null hypothesis. A very small p-val is very rare, isn't it? If 0.05 is plus or minus 2, then 0.01 is probably like plus or minus 3. Isn't that very unusual on our scale of 1 to 3? Okay, so we're going to take a look at this. We're on example 3. And example 3 says, for each claim, we're going to state the HO and the HA. We don't have to state it in words. We can just set it up. And we're going to sketch to see where we should shade for your p-val. Okay, and this we've been doing all along. I made sure that you understood this from the beginning. I didn't want to get to this point and then step back and do that all over again. So we're pretty good with this part. All we need to do is determine, is it a left tail or right tail? I'm just going to do one. This is what we've been doing. A school publicizes that the proportion of the students who are involved in at least one extracurricular activity is 0.61. How do I write this claim?
P equals 0.61.
Good. Is this the HO or the HA? Because it has an equal sign. Good. What's the HA? Not equal to. What tail test is this? Two-tail test. It says is. No, this is just at least in one extracurricular activity. This is kind of like this piece over here. If I took this out, the proportion of students who are involved in statistics. Let's just make it be statistics. Is.
So is it equal to?
Is equal to. Okay? So that's all that this is doing, and we already do this. We already went through these before. So now we're going to get to the test part. Here is the most critical part of this whole thing. Is this little box right here. We'll get into the box as well. To conclude a hypothesis test, see if I can fit this one down. You need to make a decision, and you need to interpret your decision. There is no gray area in interpreting this decision. It's either black or it's white. It's either reject or fail to reject. There is no in between. Like, I really didn't agree with this thing because it's either reject or fail to reject. And this is the one part where I absolutely need you to use the right words in this. When we go to do this, we will either say reject the null, fail to reject the null. We can't just say reject. That means nothing. Reject the null. Remember, we always test off your truth value of the null. We'll have two things that we'll test. We'll test off of a p-val. Right now, we're going to test just from your p-val. Whatever we find in your p-val, and they're just going to give it to us. In the next little section, we actually find them ourselves. We're going to say, if your p-val that you find from your test statistic, this is from your test, is less than or equal to your level of significance. This is in your notes. I suggest you embellish them. Then you say reject HO. That means it's smaller than the smallest error that we're going to allow. If P, your test, is greater than your level of significance, then you're going to say fail to reject HO. Now, when you go to interpret this, you are going to use this chart. Let's just walk through this chart. I'm actually going to make this chart and put it around the room, because this is what you're going to use every time you go to do your interpretation. You're going to find out what is your claim. So let's say we just did this one. The claim was 61% of the students are involved in at least one extracurricular activity. This was my claim. I'm going to come here. So say I had a p-val. Say, okay, let's do this. I had a level of significance of 0.05. My p-val happened to be 0.03. Watch up here. P-val versus level of significance. 0.03 versus 0.05. Is this smaller, greater than, equal to? 0.03 compared, it's less than. So it's less than or equal to. That means my decision is to reject the null statement. This happens to also be my null. So, when your claim is your null, and you rejected your null, here's your interpretation. It's just an example, but we just used the example before when we said the proportion of the students when we set up the two-tail test. So I just pulled that information down, because it doesn't make sense if I don't give you anything to look at. Your claim is your null. You say claim is your null. You rejected. This was your decision. This is what you use to interpret it. There is enough evidence to reject the claim that the proportion of students who take an extracurricular activity is 0.61. That's what I'm going to expect you to tell me back. There's enough evidence to reject. Now, look at this chart. Notice whenever the claim is HO, it uses the word reject. So if my claim is HO, and let's say now my p-val was 0.07. So here I am at 0.07, I'm comparing it to 0.05. 0.07 compared to 0.05 is greater than. So now my decision is fail to reject HO. Notice I didn't say they made a false statement. I say fail to reject HO. I come here to my chart, I say my claim is my HO. I failed to reject it. Here's my interpretation. There is not enough evidence to reject the claim that the proportion of students who have at least one extracurricular activity is 61%. Does this make sense? You really, really, really have to listen. Okay? Every time you use the claim as the HO, notice both words say reject in there. You never say, if you fail to reject this, and you say there's not enough evidence to reject the claim, that means I agreed with this claim, didn't I? If I didn't reject it, I agreed with it. But I'm not going to say, yeah, the claim was good. I like the claim works for me. I can only say, at this point in time, there's not enough evidence for me to reject this claim. I agree with it, but my statement has to be this.
How do you know how to make that decision?
The decision is based right now on our p-val. We didn't get to test it yet, so I just pulled a random p-val just so that you see how the chart works. But we're going to be doing that next, finding your p-val.
They'll always just give us two random numbers.
No, you're actually going to find, they'll give you a level of significance, just like we gave you a confidence interval all the time. We'll give you a level of significance, but we're going to give you information to find your own p-val. But remember I said, like, this part first is just learning all the parts to it. So I realized they don't fit yet, so that's why I pulled up a p-val so you could follow this chart. Okay? Second scenario. Alright, second scenario. Say my claim this time is my proportion of students who go on to take statistics in college. Here's my claim. My proportion of students who take statistics in college is greater than 25%. This is my claim. Is this my HO or my HA? HA. No equal sign. I'm making this up, guys. This is not in your book, but we're going to follow your chart. So now, when you look at this claim, you say the proportion of my students that go on to take statistics in college is only 25%. Is greater than 25%. I find that hard to believe. If they took it in high school, why do they need to go on and take it in college? So I challenge this. So I do my own sample. I come up with my rule. I find out, just give me 1 minute to wrap this up. My p-val after retest is 0.07. So I'm going to test this against my 0.05. And I'm going to say, fail to reject my HO. No, just hang on. Now my claim is my HA. I failed to reject my HO. That's not my HO. That's not my claim. My HO is this. I failed to reject that it was less than or equal to. If I failed to reject that, could I agree with my claim? If I fail to reject this, that means I took this. I can't agree with my claim. There is not enough evidence to support the claim at this point in time. Whenever your claim is HA, you're going to use the word support. I know this is a lot to digest, but my goal in this is so that we get